Okay, so today's molecule of the day is called isooctane. I put isooctane in quotes because that's not the actual IUPAC name of that compound. So this is a component of gasoline, makes up about 10%. And most of the compounds in gasoline, well, I don't know, maybe 70% of the composition of gasoline is just alkanes that look kind of like this with various numbers of different of carbons. In particular, this is the kind of the set point for 100 octane. So the octane rating is essentially a measure of the flammability of the fuel. Obviously, it's gasoline, so it's flammable regardless what kind of gasoline you have. But I think how it goes is the higher octane rating is very slightly less flammable than the lower octane rating. So essentially, the octane rating is a measure of flammability, where it's actually backwards. So isooctane is somewhat less flammable. That's why I say it resists engine knocking, because engine knocking is caused when the fuel is combusting either too violently or too soon. Sorry, I'm a car nerd. And then N-heptane, which is just regular heptane, straight chain of 7 carbons, is a 0. And so that doesn't necessarily mean that 100 octane fuel is pure isooctane. That's definitely not the case. But it's just sort of a standard so that they can measure different octanes of fuel. Anyway, so what is the IUPAC name for this? First of all, it's called isooctane, but is the IUPAC name going to be octane? No. So the reason it's octane is because it's got 8 total carbons, at least if I did it. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. But what's the longest chain of carbons here? Yeah, it's pentane. And pentane, so we'll number it 1, 2, 3, 4, 5. And we number it this way, sorry, from left to right rather than right to left, because we have 2 methyl groups on that carbon on the left and only 1 methyl group on the carbon on the right. So it's better to have those 2 methyl groups on the lower numbered carbon. So that means that we're going to have 2, 2, 4 trimethyl pentane.
Are snakes where we got the 224 from?
Yes. So our pentane carbons are here in blue. And then all the other carbons are substituents. And so in this case, all of the gold dots are CH3 groups. And so that means these are also methyl groups, because that's what a CH3 group is. And so we've got 3 of them, so that's where the tri comes from. And then the locant numbers are just the carbons in the main chain that those methyl groups are on. So there's 2 of them on carbon 2 and 1 of them on carbon 4.
Thank you.
Yeah. Okay. We have one very brief thing of new material, and then we're just going to do some practice. So we've just talked about, so far, hydrocarbons. Obviously, not all molecules are hydrocarbons. In fact, the vast majority of interesting organic molecules are not hydrocarbons. And so, as I said, we're going to get to individual functional groups as we go through this semester and next semester, introducing each of those functional groups individually. But for now, we're only going to do molecules with halogens on them. Okay. So your first instinct is going to be wrong, unfortunately, in this particular case. You're going to say, okay, the longest continuous chain of carbons is horizontal in this case. And that's true. So if we did that, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be a nonane. However, we have a fluorine down there on that carbon atom. So be careful that you notice that this is a carbon atom right here. Okay, the fluorine is not directly connected to the parent chain. And I say parent chain in quotes because it's not going to be the parent chain. The parent chain is going to be the longest continuous chain of carbons that includes the halogen. So I say if possible. I don't think there's going to be any cases where it's really difficult to decide. I might have one in here. But the parent chain really should include the halogen. And in this case, that comes at the expense of the parent chain not being the longest continuous carbon chain. Another way that you can sort of, at least for this particular example, in fact, if you don't do this, you'll end up coming into a bit of a roadblock. So if you say that the horizontal chain is the parent chain, then you've got a substituent here, which is a CH2F group. And there is a way to name that, but we haven't talked about that. So just pretend that doesn't exist. That would cause, an issue. You wouldn't be able to write an IUPAC name for that, at least based on the stuff that we've learned. So, but this we can do, right? So this parent chain, okay, we're going to start here for the numbering to keep the lowest substituent as low as possible. And now, okay, we've got a fluorine substituent on carbon 1. Oh, by the way, it's 6 carbons, so it's a hexane. Fluorine on carbon 1. And then on carbon 2, what is the name of that alkyl group? It's 4 carbons. Butane, in this case, it's going to be butyl. And so if I'm consistent here, instead of saying fluorine, I should say fluoro. And that is a good side note, in fact, to put here is, so the halogens, fluorine becomes fluoro, chlorine becomes chloro, bromo, iodo. Okay, sorry. And then butyl on C2. B comes before F. So we're going to have the butyl go first. So 2 butyl, 1 fluorohexane. Butyl. Okay, that comes from your functional group chart. The butyl group is right there. So that's a 1, 2, 3, 4 carbon chain. You can call it N-butyl. That is a more specific term that tells you explicitly that it's a straight chain rather than branched, like the other three directly below it. But that's not required. You can just call it a butyl group. And so even though these, so from here upwards, are all substituents, having an R group on them, we're still using the same prefixes from the regular straight chain alkane naming. Methyl for 1 carbon, ethyl for 2, propyl for 3. So there's N-propyl and isopropyl, also has 3. And then there's 4 different kinds of butyl groups, all with 4 carbons. Again, but being the prefix for 4. Now, this sort of thing where you have to pick the chain that's not the longest isn't always going to happen. In fact, it generally happens less often. Usually you'll just be able to treat it like any other group. Or you don't have to renumber the chain or anything like that. Okay. So go ahead with the people next to you, take a stab at these, which I don't think are in the extra homework problems. And after a while, we'll go over these. And then additionally, after this, I want to review functional group naming. So I've got I'll give you a sneak peek here. Some molecules with various sorts of functional groups. Just to get you some practice recognizing them in molecules, which I think is the trickiest part of that. So work with your neighbors for a few minutes on these. Ooh, by the way, I told you that the IR spectrometer that we had ordered was supposed to ship. Well, it got here this morning. And so hopefully in lab at some point toward the middle or the end of the semester, you guys will get to use that instrument. So I know you're probably like, I don't, whatever, but it's gonna be fun. Also relevant because next time we're going to start talking about IR spectroscopy. So. Yes. So there's no. But yeah, so no full charges. So.
I'm trying to give that.
It's very, it's like.
Yeah.
Solid difference.
Yeah, and honestly. Yeah.
Let's see, where,
Right.
we're A. Six. So this carbon right there has two groups of two. So one of them has to, so six. And then, so constituents are going to be that's one carbon right there, and then a two carbon. There's only one type of two carbons.
Like after you take that part.
So then we're deciding one is meth, two is. Site. It's four.
Cycles.
So two is so. Yep. ET, it's. That means. Yep. It's just.
Yeah. So when it was like, no, I thought it's, yeah, so it was this.
That's right. One. Sign. Sign.
Yeah, yeah. Oh, there's no little big, it's more. So that's why. It's like, this one came.
Cycle of dots. We need to pick carbon one. So. What direction? Yeah.
No, I think so. We can.
This is great.
Oh, you're fine.
Oh, shouldn't stop.
Okay. Yeah, but. No, it's right. So it's. Yeah. Then switch to. Right, just here.
C's just need these copies. I don't think they each.
They're really hard copies. I'll go the other. On its.
We just need.
I like it.
Where do we go on? Oh, the two software.
Yeah, the 1, 2 versions. Yeah.
Sorry. Oh, that's, yeah, that's. On the side. It's like, wow.
Yes, that's connected. Sorry.
That's.
I think he has more like.
No.
I'm sure it was that. I think this is the best way to see that.
Would be a sign first. Your cycle.
Is it not just a done?
Your cycle.
No, that's right. Right.
What is that first cycle?
It's these. Okay, all right. Right. Your mind is wait, am I supposed to put it on that? So that's what we have to get down. No, it's 3 times. Yeah. That's a prefix, it is out. Yeah.
So if there's one symbol. Yeah.
Six. No, it's just a little bit. Yeah, it's in, I think open it. It's just brain or not.
So.
Oh.
That's yes.
So
Look at the chart. Just thought it was smart. Doors. Okay, no.
I think
Roll forward. I think there were just all. And.
well, if it's another one, let's start teaching people.
Exchange. Be a.
Try to enlighten him. I'm so. It's okay.
It'd be a two methyl.
Three,
This is the third.
right, yeah,
One.
three,
Yeah, yeah, it's great. I don't even know if you would have, but I said, I'm sure that's.
sorry.
Maybe.
Sorry.
There we go. Let's read it. There we go. I think like.
Well, so a CH2, CH3. That's a 2-carbon chain.
That's like two.
So they combine.
Give it that filter glass. Did they? I could get people. D looks so. So it's not actually, so it's a site where there's.
Pretty much. So you should also rewrite. It's not. Actually.
Is this? This one's it, yeah.
Okay, good. Yep.
It's a propel on that side. Because the others are over there. If you look on the carbon.
Yeah.
It's an angle on top of it. Oh, hold on.
Because like it could be.
One, 3-dimethyl.
Provided.
Hey. Let's see. What's your term? Hexane.
It's just a weird. That's not.
That fun too, and yeah.
Circle back city, which overall exists. Right.
That's the region I understand. Like, for instance,
Four view order the way. They see that we are doing the same with the. I get something that knows me.
yes, I mean, that would take off like. But yes, you do have to actually program it.
So why?
This is very basic. I should.
Like,
It is.
Right, there's a difference. At least it's probably getting a little.
Doesn't matter where they are. Correct. Yep. Yeah, you want the lowest number for,
Let me think that was.
lowest number.
I was gonna get. So you can listen. This.
You would have looking for it, you got it from
This is the. I think there's.
So. Calculate
Our door was free.
the top branch has 1, 2, 3, 4. The bottom one has 1, 2, 3, 4.
Dining.
This one is,
I'm not full of this one, started, I just had to find it on the list.
and at that point, it doesn't matter. It's matter. It's about four.
Because this is an actual. It's my brain.
So this is just that providers.
Yeah, well, it's just because.
Where is my death?
Here.
Yeah, that's right. I did. That's really. I couldn't. So then that would be. Now, so I found. Right.
I'm gonna wait for anything left over there.
You got it right.
Because that's too far. So that's a mental.
That's always my favorite.
So here, you should start. I've never done a field shop.
Oh.
You can actually go either start at either one.
Whatever I do, get it.
You don't want to start an emotion in the middle of the.
I don't think I'm not wrong. I think that's it.
It's gonna be the right thought. Well, that doesn't minimize. Start either there. It doesn't matter.
If I got the first four round, I don't think you can take it. This is such.
I just. I don't know what else. That's all for F.
Yep, so F has 2 possible answers. So the parent chain is going to be the cyclopentane ring. And the question is, well, we want to minimize substituent numbers, so we're going to start here and go 1, 2, 3, 4. And that gets all substituents as low as they possibly can. Or you can start here, 1, 2, 3, 4. That also gets the substituents as low as possible. And so technically there is a way to pick between the two, but we're not gonna talk about that. So those are both equally correct. No, don't start with the halogen here because the halogen is already in the parent chain or directly attached to the parent chain.
Are you able to move it this so I can finish?
Oh, sorry. Yes.
Can you explain what that's?
B. Okay, so for B, let's see. For B, the easiest thing I think to do is to redraw it without the condensed. That's ugly. So that's it redrawn without the condensed structure, all the letters and stuff. So that kind of helps you see the carbons. Those carbons are easy to see, but mainly for this 2-carbon group on the bottom right, that's 2 carbons, a CH2 and a CH3. And if you draw out the hydrogens explicitly, you should be able to see how that equates between the skeletal and the condensed structures. So then we count carbons to cycloheptane, 7. And then as far as numbering goes, well, we want to start at the group or at the carbon with the most substituents. That minimizes the numbers. So 1, 2, 3. All right. And then we've got 2 methyl groups. So the CH3 is methyl, CH3, methyl. And then the chain of 2 carbons, methyl is 1, 2 is ethyl. And so CH2CH3 is an ethyl group. So then ethyl comes before methyl. We ignore the di for the alphabetization. 1 ethyl, and then there's methyl groups on 1 and 3. So it's 1, 3 dimethyl, total of 2 methyl groups, cycloheptane. Easy as, right? Okay, let me go over all the other ones that I didn't talk about. All right, A, the biggest culprit, I think, for A is you have to watch this dangling carbon atom on the bottom right. That is part of the parent chain, because the parent chain is the longest continuous chain of carbons. And so rather than being a 1, 2, 3, 4, 5 pentane with an ethyl group and 2 methyl groups, that last CH3 is also part of the parent chain. And so for numbering, we're going to start on the left. That gives us a methyl group on carbon 2. and then ethyl on carbon 4. For C, we kind of have the same thing going on here. You can start here or here. Either one of these can be part of the parent chain versus a substituent, doesn't really matter. But then it goes like that. And then regardless of how you do it, there's going to be 3 methyl groups. And you want to start your numbering over here in order to have 2, 3. Those 2 methyl groups be on the lowest possible numbers. E, hopefully that's self-explanatory. Let's see, G. I think that one is fairly straightforward. Cyclobutane is a square. And then we'll start the numbering at the 2 methyl groups because there's 2 groups there, and that puts 2 groups on a low number of 1. And then this chain, 1, 2, 3, 4 carbon atoms in a straight line, that's butyl. And then for H, main carbon chain goes like this, but there's a longer chain here than there is here. So it's going to go like that.
Could it also be 5-chloro?
5-chloro-4 ethyl. Wait. Yeah, you could do it the other way around. You would have to flip the 3 and the no. Yes, no, you're right. Sorry. Yes, you could also have 5-chloro-4 ethyl. CH3 is a methyl group, and then here I've used ET as the abbreviation for ethyl. That's fair game. I could have also written, let's see, CH2, CH3. Well, hopefully not crashing into the other one, but you can do that. Or I could have written that also. 3 ways to write the same thing. Questions? Yes.
Like from the left to the right?
Which one?
D.
B is in
No, D as in
D is in dog. Sorry.
here.
Let's see. So for the numbering here, the cyclohexane ring is going to be the parent chain. We're going to start numbering here where there's 2 different groups on the same carbon, because that gives us 2 number 1s in the numbering. If we started here, it would be 1, 2, 3, 4. So there'd be 2 4s. And we'd rather start here and then go clockwise.
Okay.
I don't know if that explains it.
Or did you just stay in the center like? Okay.
Yeah, so I went clockwise in this case, because if I went this way, it would be 1, 2, 3, 4, 5 instead of 3, 4.
And you always stay in the.
Yep, always stay in the ring. So I should be complete here and do 5, 6. I guess I should fix that one as well. All right, we're good? Cool. Okay, so get out, I mean, you probably already have your functional group chart out, but get an extra out. So for this, just name as many functional groups as you can in all of the molecules. Generally speaking, methyl groups, I don't really care that much about, but it's not wrong to name them because that's what they are. So, for example, if you said that is a methyl group, that that's okay, but of course, make sure you can name the other ones as well.
So. Confidence. Yes.
Yes. Because if the carbon that the alcohol is bonded to has carbonyl on it, no bond to oxygen, the whole group is carbon selected. But in some ways, it acts kind of like, but So sometimes you have to look a couple atoms around the functional group to make sure. So in C, for example, the nitrogen. A lot of times you see nitrogen, you say, oh, it's an amine. But it's got carbonyl next to it. So it's amide. Yep. Okay, so, and it's a lot. There are some groups that I didn't label, again, like methyl groups, I didn't label. For example, in this tert butyl group here, the tert butyl group is just 3 methyl groups attached to a central carbon atom. So it is both a tert butyl group and 3 methyl groups at the same time, kind of. Oh, I forgot one at the end. Sorry. What else? So there are so many different kinds of carbonyl based functional groups. So carbon double bonded to oxygen. That when you see one, you need to make sure that you look next door to it in both cases. So this is a ketone, and it's a ketone because we've got 2 sp3 carbons next to it. This is an amide because we've got a carbonyl with an sp3 carbon and a nitrogen next to it. This is an acid halide. It's a carbonyl with an sp3 carbon and a halogen. Acid anhydride kind of looks like it might be an ether because it's got an oxygen with 2 carbons attached to it. But further than that, it's an oxygen with 2 carbonyl groups on either side. That's what makes it an acid anhydride. What else? You don't necessarily have to label cycloalkanes. I'll specify if I want you to do that. What else? Alkenes versus alkynes versus alkanes, of course. Make sure you get those that third to last letter correct on each one. And then there's several different ways I've drawn ethers. So these, let's see, there's a, oh yeah. At least this many. So there's one here, oxygen with a carbon on one side and a carbon on the other side. Oxygen with a carbon on one side and a carbon on the other side. Oxygen with 2 carbons. And for example, in this case with the Ne, you'd have to know that that is a methyl group and that gets expanded into a CH3. Okay, and then let's do the last one here at the bottom. What about that last carbonyl group? What's that one? Yep, aldehyde.
That one is the same as like or there's a double. What is it?
Carboxylic acid. So the difference between an aldehyde with no oxygen atom there and carboxylic acid does have an oxygen atom there. And in fact, they're very different in terms of their reactivity because a carboxylic acid, right, it's almost got what looks like an alcohol in it. It's really not an alcohol because it's part of a larger functional group, the carboxylic acid, but that's going to act like an alcohol in some cases. The aldehyde doesn't have that OH and it doesn't react at all like an alcohol. Oh, sorry, the quaternary, kind of the low-hanging fruit here. So nitrogen with 4 things attached to it. That's a quaternary amine. And you'll notice it's got a positive charge because quaternary amines always have to be positively charged. And just to keep things balanced, I've included a bromide anion to go along with it, but that's not really an organic functional group, so we don't care about it. In a lot of cases, people just wouldn't write that at all, even though that's just because it's a ring of carbon atoms that are all sp3 hybrids. Yeah.
I wanted you like both.
It is. Specifically, it's a cyclopentane. Same for up here. That would be a cyclohexane. Let's see, this is cyclopentane. You can't say that this is a cycloalkane because it's not all carbon types. You got a sulfur in. If you're still having trouble with these, which that's totally okay, what I would do is just Google like acid halide structure examples and look at the images, and it should give you a whole bunch of various acid halides, so you can see sort of how they look in different environments. I would hesitate to ask ChatGPT to do that, mostly because ChatGPT, okay, so it's great and all. The problem is it really loves condensed structures because it doesn't know how to draw skeletal structures. So if you're okay with it giving you a condensed structure, and then, hey, you could practice drawing a skeletal structure out of that, then you can use ChatGPT for that sort of stuff. But just fair warning on that front. Questions on functional groups? Yep.
Gonna be like on the test.
Yeah, so I'll probably give you like one of these, maybe not with a bunch of crazy functional groups, but okay. This I don't think this will sound good to you right now, but probably what I will do is give you a molecule like that, ask you to name the functional groups, and ask you to match it to an IR spectrum, which I know it sounds difficult. It's actually pretty easy. And that way you'll have like the IR stuff, you're going to get a chart, a table with all the values. So you have to memorize those. And once you start seeing certain things in the IR spectra, you'll start matching those to functional groups, and it'll sort of, I think it'll help you remember it a little bit better. So I might do something like that.
We can make like a functional like group chart, like periodic table of the other.
You're not going to get the functional group chart, but you will get a periodic table. I'll give you electronegativity values if you happen to need those. Periodic table, but not the functional group chart. Okay. Next time we will just do IR spectroscopy. It will be one day. We'll get it done. And then so next Tuesday, you need to bring your molecular modeling kits. So if you don't have that ordered, get on that. All right.